Hello, this is Abdurrahman al-Fintukh and I will be explaining the surface anatomy of the kidneys. So it is important to know the exact location of the kidney in relation to the vertebral column and also the rib cage, because the surface anatomy is important in surgeries and also in palpating at different organs in the abdominal and thoracic cavities. So I have this figure showing the posterior aspect of the vertebral column that includes also the rib cage and other organs, but most importantly the kidneys. And the reason why I'm viewing the kidneys posteriorly, not anteriorly, is because if we look from anterior, the kidney is completely invisible and they cannot be seen because they are hidden inside the abdominal viscera. And let us talk about the kidneys in particular. So both of the kidney, they are similar in shape, but when it comes to the position, they are slightly at different levels. So the right kidney is at lower level because the liver is pushing it down, is forcing it down, and the upper pole of the right kidney is just touching the 11th rib, and the 11th rib is not covering the kidney entirely, but the 12th rib is actually covering the right kidney entirely. And both of these ribs also are known as the floating ribs, because they are never reach up to the front. The lower pole of the right kidney is reaching up to the third lumbar vertebrae. Now let us took a look to the left kidney. It is obviously higher when it comes to the vertebral level, because there is no liver present in the left side, and it is just the stomach and the spleen. The left kidney is reaching above the level of the 11th rib, and the posterior surface of the left kidney is covered by both of the floating rib, the 11th and the 12th. That means it is more protected as compared to the right kidney by the rib cage. Also, its lower, or let us say inferior pole, is reaching up to the level of the second lumbar vertebrae. And I'm going to draw an imaginary line here. Is called transpyloric plane. Transpyloric plane is important to describe the abdominal visceral organs, and I'm using it here especially to compare between the right and left hilum. So the hilum of the right kidney is slightly lower and slightly lower than the level of the transpyloric plane, while the hilum of the left kidney, is at the level of the transpyloric plane. Thank you for listening. This is Abdurrahman al-Fintukh and I will explain the anatomy of the kidney. So the kidney is around 120 to 200 grams and not that long, about 10 to 12 centimeters and 4 centimeters thick, and about 5 to 6 centimeters wide. And the kidney consists of two poles. We have the lower pole, we call it extremitas inferior, and we have the upper pole, we call it extremitas superior. And in the upper pole you can find the suprarenal gland. So the kidney has two margins separating the anterior and the posterior. We have the lateral margin here and the medial margin here, where you can see the hilum renala, where lymph and blood vessels and nerves go in and out. And so let's get into the microscopic level. This is a kidney that has been cut in half, so we can see the structure within the kidney. Let me start from the outside, moving inward. First of all, we have the renal capsule or fibrous capsule, which is a tough fibrous layer surrounding the kidney. Within the capsule, there is two major divisions within the kidney. This outside layer we call cortex, and the inside layer we call it the medulla. And microscopically we can see the pyramids, not here, here the renal pyramid, which is slightly darker than the surrounding cortex, and we can also see the renal columns here, which is separate the renal pyramids from one another, and also the columns carries blood vessel to the cortex. um, the urine. Let's talk about the urine. The urine is carried by the small tubules called collecting ducts, which run down through the renal pyramids, and then through something called renal papilla or papilla, and which is where the pyramids make the minor calyx, and from the minor calyx then flows the urine flows from the minor calyx to the major calyxes here, which empties into the renal pelvis and eventually flew to the ureter here.
Bismillah ar-Rahman ar-Rahim. My name is Aziz Ahmed Traigi. Today I'm going to talk about the kidneys and its blood supplies and venous supply and venous and lymphatic drain of the kidneys. So, of course, the kidneys are the primary functional organ of the renal system. They are essential in hemostatic functions such as the regulation of the electrolytes, maintenance of acid-base balance, and of course the regulation of blood pressure. They serve the body as a natural filter of the blood and remove wastes that are exerted through the urine. So we have here a little description about the kidney. It filters the blood and secretes urine to eliminate toxic substances and waste from the body. So when we talk about the blood supplies, we can say that the blood supply is we have renal arteries and we have aorta, abdominal aorta, and we have inferior vena cava, and we have renal veins. So we should save these four things because we can say in conclusion, the blood to kidney, we have the abdominal aorta and the renal artery, left and right. And from the kidney, we have the renal vein, of course, right and left, and we have the inferior vena cava. So, when we talk about the nerve supply, we can say that the renal nerves arise from the superior mesenteric ganglion and enter the hilum of each kidney. They follow, of course, as we can say, they follow branches of the renal artery to reach individual nephrons. I have some photos. So this is the blood supply and the venous supply, and this is the nerve supply. These nerves consist mostly of sympathetic fibers that regulate the blood flow into and out of each nephron, and those control the rate of filtration and urine formation. If the blood pressure falls, they also stimulate the nephron to secrete renin, which ultimately restores blood pressure by mechanisms. We have this photo here. It's talk about the parasympathetic fibers leads into contraction of smooth fibers in ureter and bladder and relaxation of smooth fibers. Sympathetic fibers cause the opposite effect. Sympathetic fibers to kidney are vasomotor comes from renal plexus. So this is a photo for venous drain. We can see the arcuate vein, the superior trunk, the main renal vein, the inferior trunk here, and the interlobar vein. I'm sorry about the photos, but my possibilities is not very highly. I just have this program. So here also we have the venous. Drain. We can see the interlobar arteries, interlobar veins, And this is the photo of nerve supply, renal plexus, and the sympathetic and regulation blood flow to the kidney by causing vasodilation or vasoconstriction of renal arteries. This is the veins, spinal nerves. And this is a photo for lymphatic drain. We can see here the kidney. Lateral aortic nodes located at the origin of renal arteries, filtering and phagocytosis, proliferation of lymphocytes. And here we have like 7 points. And that's it from my side. And thank you very much for listening. And I want to special thanks for Dr. Muhammad Juma for his patience with us and for his kindness. And I'm sorry for my possibilities because I don't have a lot of resources. I'm outside of Riyadh and I just have my cell phone. So thank you very much.
And today, inshallah, I will talk about the ureters. The ureters are a tube made of smooth muscles fibers that propel the urine from the kidney to the urinary bladder. The ureters attach to the hilum of the kidney to the posterior of urinary bladder. Here we see this is the urinary bladder and this is the posterior of the urinary bladder. And as we know, we have the right ureters and we have left ureters. We will start by the right ureters. In the interior of the right ureters, we have here the duodenum. Just see the digestive, and we will understand more. Just hide. Okay, here the duodenum. If we hide the duodenum, we will see the right ureters. Here just hide it here. Yes, this is the right ureters, and also we have the terminal part of the ileum. Just if we hide the ileum, now we see the right ureters. So the duodenum and the terminal part of the ileum is located anterior to the right ureters. And also we have some vessels that related to the colic, and also we have the right testicular vessels in male and the right ovarian vessels in a female. This is just like hide this. Here for example, this is the artery, the testicular artery, and also we have the same of this like testicular vein. This is in male testicular and in the female ovarian arteries. And also we have the roots of the mesentery. As we know, this is the roots of the mesentery located here to the anteriorly to the right ureters. From the posterior, we have this large muscle, which is the right poses muscle or poses major muscle in the right poses muscle. And also we have the common iliac artery, and this is very important and dangerous. The common iliac artery, we have this the external common iliac artery, and we have internal common iliac artery in the right. For example, if you are a surgeon, you wouldn't be cut like iliac artery. You have to be sure that you cut the right place, which is like ureters, because in the operation room, this area will be so bloody. If you don't understand the anatomy very well, you maybe make a big problem. Now let's go to the right ureters. The right ureters, we have the sigmoid colon. Just see like here. Okay, let's hide it like this. Let's hide this. Okay. Yes, this is the interior of the left ureters, we have the sigmoid colon, and as we see, this is the sigmoid colon located anterior to the left ureters, and also we have some colic vessels, and also we have the testicular artery, and also we have testicular vein. This is the testicular artery, and in male. And from the posterior of the left ureters, we have also a poses muscle, the left poses muscle, and we have also a common iliac artery, which is we have external iliac artery and internal iliac artery. Just hide this, and also yes, this is here the external iliac artery, and here the internal iliac artery from the posterior of the left ureter. Now let's go to the blood supply of the ureter. Just finish from the digestive. Yes, now we will go to the blood supply of the ureters. In the upper of the ureters is supplied by the renal artery. Here we see here, this is the renal artery. Here from the upper part of the ureters, supplied by the renal artery. Here the renal artery, and also from in the right the same. Here this is the renal artery. See, this is the renal artery in the left, and in the middle is supplied by the testicular in male, or ovarian artery in a female. This is here. This is the testicular artery. See, this is here. This is the testicular artery. The ureters is, from the middle is supplied by the testicular artery. The ureters in the pelvis, here, see, like in the pelvis, is supplied by this artery, which is called superior vesical artery. Here, this here, this is superior vesical artery from the right, and we have superior vesical artery from the left to supply the ureters from the pelvis area. What about the lymphatic drainage? The lymph drains to the lateral aortic nodes. Here, this is the lateral aortic nodes. You see this is just to see it very clearly. Here, see this the green ones. Here. This is the green ones. We call this the lateral aortic nodes. And also lymph drains also to the iliac nodes. Here we have the iliac nodes. This is here, we call this the iliac nodes. So we have lymph drains to the lateral aortic nodes and iliac nodes. And what about the nerve supply? We have the uterus get the signals from the we have the renal nerves, which is located above the aorta. There is a lot of nerves here. I'm sorry, I cannot show you because this program, but here there is a lot of nerve which called like renal nerve. The ureters get supplied from this renal nerve, and also like the testicular or ovarian nerve, and also the hypogastric plexus in pelvis. This is hypogastric plexus. See all see this is in the yellow. Sorry. This is in the yellow. This is the hypogastric plexus. This is superior, and this is the right hypogastric plexus, and this is the left hypogastric plexus. And also this is get a signal to and this nerve supply to the ureters, and the afferent fibers of this afferent fibers travel with the sympathetic nerves and enter to the spinal cord from the first and second lumbar. This is first lumbar, and the second lumbar goes to the spinal cord. I hope I cover everything. Thank you.
Assalamu alaikum wa rahmatullahi wa barakatuh. My name is Mishal Frayana, and today I will talk about the anatomy of suprarenal gland with its blood supply and nerve supply and lymphatic drainage. We have two suprarenal glands in our body, as we can see here and here. The two suprarenal glands are yellowish retroperitoneal organs that lie on the upper poles of the kidney. As we can see, they are surrounded by the renal fascia and separated from the kidneys by the perineal fat. Each gland has a yellow cortex and dark brown medulla. What we can see here is the cortex, not the medulla, because the medulla is inside the suprarenal gland itself. I will talk about the left suprarenal gland now. It's crescentic in shape, as we can see, not pyramidal. Extend along the medial border of the left kidney from the upper pole to the ileum. It lies behind the pancreas, the liver sac, the stomach, and it rests posteriorly on the diaphragm. Now we are moving to the right suprarenal gland. The right suprarenal gland is pyramidal in shape, and it's on the upper pole of the right kidney. It lies behind the right lobe of the liver and extends medially behind the inferior vena cava, and also it rests posteriorly on the diaphragm. I will talk about the blood supply. We have three arteries supplying each gland. We have superior suprarenal artery and middle suprarenal artery, and we have the inferior suprarenal artery, and the same on the right suprarenal gland. The superior suprarenal artery comes from inferior phrenic artery, and the middle suprarenal it comes from aorta. Sorry, I cannot show the main arteries because there is a problem in this application. Every time I show it, it kicks me out. And the inferior suprarenal artery, it comes from renal artery. Now I will talk about the veins. A single vein emerges from the ileum of each gland, as we can see. The right suprarenal vein drains into the inferior vena cava, and the left suprarenal vein drains into the left renal vein. Now I will talk about the nerve supply. We have one nerve in each gland. We have right suprarenal plexus and left suprarenal plexus, as we can see here. It distributes sympathetic fibers to the suprarenal glands, in particularly its medullary portion. As for example, if we have accident, we need adrenaline, and the nerves stimulates the hormone. These fibers arise from the celiac plexus, the celiac ganglion, the phrenic nerve, and the greater splenic nerve. Now we are moving to the lymphatic drainage. The lymph drainage is to the lumbar lymph nodes by adrenal lymphatic vessels. These vessels originate from the two lymphatic plexus, one deep to the capsule and the other in the medulla. As I said before, there is a problem in this application. I cannot select the lymph nodes that I want. I hope my explanation was clear. I tried to shorten it as much as possible, and